In the year 1977, NASA launched two robotic spacecraft, Voyager 1 and Voyager 2, on a mission to explore the outer planets. Decades later, they are still traveling through space, now far beyond the influence of our Sun. Voyager 1, currently more than 15 billion miles, 25 billion kilometers, from Earth, holds the record for the most distant human-made object. But after nearly 50 years of operation, Voyager 1 encountered a serious problem, one that threatened to end its legendary journey. A key set of thrusters that help keep the spacecraft properly oriented stopped functioning, raising the risk of total communication loss. Against all odds, NASA engineers pulled off a miracle by bringing these long inactive thrusters back online, just in time to avoid a blackout in communications. Let's explore how this dramatic save unfolded. A critical failure in the depths of space. Voyager 1 needs to keep a large antenna aimed precisely at Earth to send and receive signals. It does this using small thrusters that control the spacecraft's orientation, its pitch, yaw, and roll. The roll control, in particular, helps the spacecraft spin gently, like a record, to stay locked onto a guide star. Voyager 1 has both main and backup sets of roll thrusters. Back in 2004, the primary roll thrusters stopped working. Engineers suspected it was because internal heaters failed, making the thrusters too cold to function. At the time, this wasn't a major concern, they simply switched to the backup thrusters, which still worked well. No one expected the spacecraft to last this long anyway. But by early 2025, after decades of wear and tear, even the backup roll thrusters began to show signs of trouble. Residue built up inside the fuel lines, and performance dropped. Without working roll thrusters, the spacecraft would drift off course, and its antenna would lose contact with Earth, effectively ending the mission. To make matters worse, NASA's only antenna powerful enough to send commands to Voyager, Deep Space Station 43, DSS 43, in Australia, was scheduled for upgrades between May 2025 and February 2026. If Voyager lost control during this time, it would be impossible to restore contact. With time running out, NASA's Jet Propulsion Laboratory, JPL, had to try something no one thought possible, reactivating the primary thrusters that had been silent for over 20 years. Reviving the dead, engineering against the odds. The engineering team suspected the original failure of the primary thrusters wasn't permanent damage but a power switch issue that turned off the heaters keeping the thrusters warm. If that was true, there might still be a way to turn them back on, if they acted carefully. However, this plan came with high risks. If the heaters didn't work and the frozen thrusters tried to fire, they could explode or damage the spacecraft. On top of that, if Voyager's orientation drifted too far during the procedure, the onboard system might try to autocorrect using the inactive thrusters, risking further damage. On March 20, 2025, the team sent carefully timed commands to attempt the fix. Because Voyager is so far away, it takes more than 23 hours for a signal to reach it, and just as long to hear back. When the confirmation signal finally arrived, engineers saw something amazing. The thrusters had warmed up, and they were working again. This was an incredible moment, said a mission engineer. We believed these thrusters were gone forever. But it turns out, with the right insight and a little luck, what this means for the mission bringing the primary thrusters back online gives the spacecraft a crucial backup, ensuring it can maintain its orientation for the foreseeable future. This success greatly improves the chances of Voyager 1 continuing its mission well into the 2030s. This wasn't the only success. In early 2024, Voyager 1 had a 5-month blackout due to corrupted memory but recovered fully, with all science instruments back online by May 2024. In February 2025, NASA made another smart move by shutting down the cosmic ray subsystem to save power, ensuring that other key instruments can continue to function. The low-energy charged particle instrument is expected to run until at least the end of 2025. These instruments are helping scientists study the interstellar medium, the space between stars. Voyager 1 is currently collecting one-of-a-kind data on things like magnetic fields, space plasma, and the boundary between our solar system and the galaxy beyond. Looking ahead, a legacy of exploration. Voyager 1's endurance is teaching NASA valuable lessons for future deep space missions. Its performance helps engineers design spacecraft that can survive far beyond the solar system. In fact, the mission's challenges have influenced upgrades to NASA's Deep Space Network, which will help support future ventures like Artemis moon landings and outer planet exploration. Clapperboard emoji, outro. Thanks for watching. If you love science, space, and stories of human ingenuity, don't forget to like, subscribe, and turn on notifications for more incredible updates from the edge of the solar system.